Welcome to your deep dive. Today, we're going deep into document parsing, and wow, you've given us a really interesting mix of sources this time.
It seems like you want to understand
Okay.
not just how computers extract information from documents, but also, what kind of impact this is having on the world.
Yeah, exactly. I
Yeah.
mean, so much of our world runs on these documents, right?
Yeah.
Contracts,
Oh,
invoices,
absolutely.
research papers,
Yeah.
even those receipts you shove in your pocket and forget about.
Right.
Imagine if all that information could just be automatically organized and analyzed.
Well, that's precisely the power of document parsing.
Okay.
It takes that unstructured data, like
Yeah.
scanned papers, images, and turns it into structured, machine-readable data, which opens up so many possibilities.
So instead of like manually going through a stack of invoices,
Yeah.
you could have a system that automatically pulls out, the vendor, the date, the amount owed.
Exactly. That's just one application, though.
Right.
Document parsing is being used for everything from information extraction to document comprehension, knowledge-based construction, and even training data for AI models.
Okay, so let's get into how this actually works.
Okay.
I noticed in your sources that there seems to be like two main approaches to document parsing. It's almost like two different schools of thought.
Yeah, you have the modular pipeline system and then the end-to-end approach using large language models.
Okay, the modular pipeline system sounds a bit like an assembly line,
Yeah,
where each step kind of builds on the last one.
that's a great analogy. It starts with layout analysis, where the system figures out the structure of the document, identifying things like text blocks, images, tables, and even those tricky mathematical formulas. Think of it like recognizing the different parts of a car, the engine, the wheels, the chassis.
So it's not just seeing the words on a page, it's about understanding how they fit together and
Exactly.
what their role is in the document.
Exactly. Once that layout's been analyzed, we move on to content extraction,
Okay.
which involves several subtasks. You have text extraction, where good old OCR comes into play, converting
Okay.
images of text into editable text. Then there's table extraction.
Right. Pulling out both the data and the structure of tables so you can easily analyze it.
Right.
And finally, chart decoding, where visual charts get turned into raw data or JSON format.
So it's kind of like taking apart the car to understand how each component works,
Yes.
and then putting it all back together.
And the final step in the pipeline is relation integration, where the system uses the spatial information from that layout analysis to understand how the different elements relate to each other.
Okay.
So going back to the car analogy,
All right.
this is like understanding how the engine connects to the transmission, how the wheels connect to the axles, seeing that complete picture.
But the other approach, using large language models, seems to take a totally different path.
Yes. With these powerful AI models like GPT-4 and Llama, we're seeing a shift towards these end-to-end approaches where a single model can process both text and images at the same time.
Hmm.
It's like having a mechanic who can diagnose a car problem just by looking at it and listening to the engine.
Wow, that's incredible. But I imagine document images come with their own unique set of challenges. Absolutely. Dense, text complex layouts, variations, and visual elements can really throw these models off.
Oh, I see.
That's why researchers have actually developed specialized large models like NuGet-Fox and GOT, which are specifically trained to handle the unique challenges of those document images. Think of them as mechanics who specialize in a particular type of car. They have that expertise to handle even the most complex problems.
So it's like a race between the meticulous step-by-step approach of those modular systems
Yeah.
and the intuitive, all-encompassing power of large models.
Yeah.
I'm curious to see which approach ultimately wins out or if they'll just end up complementing each other in some way.
That's a great point. It's not necessarily a competition,
Yeah.
but rather a case of different tools for different jobs.
Yeah.
Modular systems offer that transparency and customizability, while those large models have the potential for handling increasingly complex documents with remarkable speed and accuracy.
Let's dive a little deeper into some of these key modules.
Okay.
Starting with layout analysis, which seems to be the foundation
Yeah.
for both approaches. I understand it's not just about identifying elements on a page. It's about understanding their relationships
Yeah.
and their meaning within the document structure.
What's fascinating is how layout analysis itself has evolved. Early methods relied on rule-based systems, kind of like giving the computer a set of instructions on how to identify elements based on their size position, other visual cues, but these systems struggled with the complexities of real-world documents.
So it's kind of like trying to teach someone to drive
Yeah,
by giving them a set of rules instead of letting them actually practice behind the wheel.
exactly. And that's where deep learning revolutionized the field. convolutional neural networks, CNNs, which are great at analyzing those visual patterns, and transformers, which excel at understanding sequential data, started being applied to layout analysis. They're able to learn from massive data sets of documents and identify even those subtle patterns in layout and structure.
So instead of following like rigid rules, these systems are learning to recognize patterns in the same way that a human would.
Precisely. And it's not just about individual elements anymore. We now have graph convolutional networks, GCNs,
All right.
which are specifically designed to understand relationships between elements. Think of it like a family tree. A GCN can analyze how people are related and understand the connections between them. In document parsing, a GCN can do the same thing with document elements,
Wow.
figuring out how they relate to each other to extract meaningful information.
So it's not just seeing the elements, it's understanding that underlying structure and relationships.
It is.
That's pretty amazing.
And then there are grid-based methods, which are all about preserving that spatial information.
Okay.
They represent the document as a grid, kind of like a map, which helps with accuracy and maintaining the document's original structure.
But what about those times when a document throws a curveball? Like a table without clear borders,
Right.
or an equation smack dab in the middle of a paragraph.
Yeah.
Can these systems handle that?
That's one of the ongoing challenges in layout analysis. Inline mathematical expressions, for example, can be particularly tricky because they blend with the text and require special handling. It's like trying to separate two different colors of paint that have been mixed together.
And that brings us to another crucial module, OCR, which is the classic technology for converting images of text into editable text. It feels like OCR has been around forever.
It has a long and fascinating history going all the way back to early computers.
Yeah.
But the core principles are still the same. Locate the text within an image, decipher the characters and words.
Yeah.
And of course, today's OCR systems are much more advanced thanks to the power of deep learning.
This is like having a super-powered speed reader
Yeah.
that can scan and understand text in an instant. But how does it deal with different fonts, handwriting styles, and all the quirks of human writing?
The shift from traditional rule-based OCR methods to deep learning has been a game changer. Deep learning models can learn to recognize patterns and variations in text, even handling different fonts and handwriting styles with remarkable accuracy.
But documents aren't just about words and letters. We've got mathematical expressions, tables, charts,
Right.
each with their own unique challenges for a computer to understand. How does document parsing tackle these complex elements?
Well, let's start with mathematical expressions.
Okay.
These can be particularly tricky because they're not just about recognizing individual symbols, but understanding their relationships and meaning within a mathematical context. It's like trying to understand a sentence in a foreign language.
Right.
You need to know more than just the individual words.
So how do these systems actually decode mathematical expressions?
There are different approaches, but many modern systems use deep learning models that are trained on large data sets of mathematical expressions. These models can learn to identify patterns in the layout of symbols and understand the underlying mathematical structure. It's like teaching a computer to read sheet music.
Right.
It needs to learn the rules of musical notation to understand the melody.
Okay, now let's talk tables. Because honestly, tables can be a nightmare to work with manually.
Yeah.
How does document parsing handle these data-packed beasts?
Tables are a treasure trove of information,
Yeah.
but extracting that information can be tricky. Document parsing systems use a variety of techniques to detect and understand tables.
Okay.
Starting with object detection algorithms that can spot tables within images. Then they need to understand the table structure,
Right.
which can be done using row column segmentation, kind of like drawing lines to separate the table into its basic building blocks.
That makes sense. But what about tables that don't follow a strict grid structure?
Right.
Those creatively formatted ones that designers love to use.
Those are definitely more challenging. Tables without clear boundaries or tables that span multiple pages can be difficult to parse. It's like trying to solve a jigsaw puzzle where the pieces don't have straight edges.
And finally, let's move on to charts,
Okay.
which are kind of a visual language of their own.
Yeah.
How does document parsing decode the stories that charts tell?
Chart comprehension and data extraction are crucial for making sense of data and making informed decisions. Document parsing approaches this with a multifaceted approach, tackling tasks like chart classification, element detection, and data extraction. It's like having an AI analyst that can interpret and summarize visual data for you.
So the system needs to figure out what type of chart it's looking at.
Yes.
Bar chart, pie chart, etc.
Right.
then identify the key elements like axis labels
Yeah.
before it can even start extracting the data itself.
And here's where it gets really interesting. Chart parsing often involves linking visual elements with textual descriptions for complete understanding.
Okay.
It's a true multimodal challenge that requires the system to connect what it sees with what it reads.
So it's like having an AI that can read a chart's caption and then connect that information to the visual elements to understand the data being presented. That's pretty impressive.
It is, and this field is constantly evolving. Researchers are developing new algorithms and approaches to tackle the challenges of chart parsing, making it more accurate and robust. It's an exciting area with a lot of potential for unlocking insights hidden within visual data.
So we've gone through the key modules of the modular pipeline system.
Yes.
But now I'm curious to hear more about how those large models are shaping the future of document parsing. What are their unique advantages and challenges?
Large models are offering a more unified approach to document parsing, and they have the potential to handle a wider range of documents and tasks, all while constantly improving. But they're not without their limitations.
I imagine they're incredibly resource-intensive.
Yes, they require a lot of computational power and data for both training and deployment, which raises questions about their efficiency and practicality. But the research in this area is moving quickly. We're seeing new models and approaches emerge all the time that aim to address these challenges.
And what about those specialized large models that have been developed specifically for document parsing? What sets them apart from the more general-purpose models?
These specialized models, like NuGet and Fox, are trained on massive data sets of documents and are specifically designed to handle the unique challenges of document images. They're able to achieve impressive results, particularly in tasks like OCR and understanding those complex layouts. It's like comparing a general practitioner to a specialist. The specialist has deeper knowledge and experience in a particular area.
So it's like having an AI expert that's been trained on millions of documents and can now spot patterns and extract information with incredible accuracy. But what does all this mean for someone like me who's not a computer scientist?
Right.
How will these advancements in document parsing impact my life?
Imagine a world where you can instantly extract key information from any document, analyze trends across countless research papers, or even have your computer automatically process invoices. Document parsing is making all of that possible, and it's only getting more powerful.
That sounds incredibly useful. But what about the future? What's on the horizon for document parsing?
This field is evolving rapidly, with researchers tackling new challenges like diagram extraction and better understanding of complex layouts. The future of document parsing is about making information truly accessible and empowering us to unlock knowledge hidden within the millions of documents that surround us.
It's almost like we're giving computers the ability to see and understand the world through the lens of documents.
Yeah.
And with that ability comes a whole new set of possibilities.
Absolutely.
But let's not get ahead of ourselves. We still have a lot to cover in this deep dive, including the specific challenges and limitations of both module systems and large models, as well as the exciting new directions researchers are exploring.
Absolutely.
All right, so we've laid out the groundwork of how document parsing works. But now I'm curious about the hurdles researchers are facing. What are some of the limitations of these approaches, starting with the modular pipeline systems?
One of the biggest challenges with the modular approach is getting all those different modules to play nicely together. Each module is like a specialized tool. And sometimes those tools don't communicate as well as we'd like. It can require a lot of manual tweaking to get everything running smoothly.
So it's like having a team of experts who are brilliant individually but struggle to collaborate effectively.
Exactly.
Okay. Are there any issues with the outputs from each module? Do they always mesh together seamlessly?
That's another hurdle. Different modules might produce outputs in different formats, making it tricky to integrate the information. It's a bit like trying to build a house using blueprints from different architects. You might end up with mismatched walls and doors.
And we talked about those complex document layouts with nested elements and unusual reading orders. How are modular systems handling those curveballs?
That's definitely an area for improvement. Many systems rely on rules that can't quite keep up with those more intricate layouts. It's like trying to navigate a maze using a map that only shows straight lines.
So the system might trip up on multi-column layouts or documents that jump around a bit. What about the limitations of the individual modules themselves? Any areas where they're consistently struggling?
Absolutely. Layout analysis, for example, can still have trouble accurately analyzing those really complex layouts with nested elements.
Yeah.
Think scientific papers or legal documents. Future systems need to get better at incorporating semantic information to truly grasp those subtle, fine-grained layouts.
It's like trying to understand the hierarchy of a company just by looking at an org chart.
Right.
You need more context than just the boxes and lines.
Yeah.
And even though OCR has come a long way, I'm guessing it's not perfect yet.
You're right. Even with the advancements in deep learning, OCR still faces challenges with densely packed text, especially large blocks of it. And handling all the different font styles like bold and italics can also be tricky. It's a bit like trying to read a handwritten note where the writer used different pens and writing pressures.
And of course, there's the table conundrum.
Oh, yeah.
What are some table-specific challenges that are giving modular systems a hard time?
We touched on those creatively formatted tables without clear boundaries.
Right.
Those can be a real headache for these systems to detect.
Okay.
And when it comes to recognizing tables, processing nested tables or tables without cell borders is still an area where we see room for improvement.
Yeah.
It's like deciphering a spreadsheet where some of the cells are merged or hidden.
And mathematical expressions, those seem like a whole other level of difficulty.
You're not wrong. Detecting and recognizing both inline and multi-line mathematical expressions, especially handwritten ones, is still a tough nut to crack. It's like trying to grade a math test without a clear answer key.
And we haven't even touched on diagrams yet.
Right.
Are modular systems anywhere close to being able to handle those?
Diagram extraction is a very active area of research, but it's still in its early stages. Existing methods are often semi-automated or tailored for specific types of diagrams, limiting their applicability.
So we've uncovered quite a few challenges for modular systems. Now, as turning our attention to large models, do they face a similar set of limitations?
They do, but their challenges often look a bit different. One surprising finding is that despite their power, large models don't always outperform those modular systems.
Why, really?
This is especially true for tasks like precisely distinguishing between different page elements or dealing with intricate table structures.
That's unexpected. Why would that be the case?
Well, many large visual models keep the language model parameters frozen during their training, which can impact their OCR capabilities. And while they're fantastic at encoding those document images, decoding them accurately, especially for longer documents, can be tricky. It's a bit like having a friend who's a fantastic storyteller, but sometimes forgets key details in a long, complicated tale.
And we've talked about how resource-intensive these large models can be. Is that a major obstacle for researchers?
It's a definite concern. These models demand a lot of computational power and data for both training and deployment, raising questions about their practicality and efficiency. It's like trying to run a high-performance race car on a small, winding country road.
Yeah.
You have the power, but the infrastructure might not be quite there yet.
So it sounds like both modular systems and large models have their own sets of strengths and weaknesses.
Yes.
Is there a clear winner in this document parsing race?
Not really. It's more like a dynamic relationship where each approach pushes the other to improve.
Yeah.
Modular systems offer that transparency and flexibility, while those large models hold the potential for end-to-end learning and handling increasingly complex documents.
It's like they're two athletes training for the same event, each with their own training regimen, pushing each other to perform better. But zooming out a bit,
Right.
are there any broader challenges facing the field of document parsing as a whole?
One challenge lies in the lack of diversity in the data sets used for training and testing. Current research often leans heavily on those very structured document types like scientific papers and textbooks, while neglecting more complex documents, things like instructions, posters, and even newspapers.
So it's like training an athlete on a very specific type of terrain,
Right.
but then expecting them to compete on a completely different course.
Exactly. We need larger, more diverse data sets that represent the wide range of documents out in the world.
Right.
It's crucial for both training and evaluation. Think of it like building a self-driving car that's only been trained on highways. It needs exposure to all sorts of roads and driving conditions to be truly effective.
And does this lack of diversity also affect the development of those evaluation metrics we talked about?
Absolutely. As document parsing tasks become more complex, we need more sophisticated evaluation metrics that can accurately assess performance across different document types and tasks. Imagine judging a figure skating competition based solely on technical difficulty. You'd miss out on the artistry and overall performance.
So the evaluation metrics need to keep pace with the algorithms and approaches themselves.
Yes.
Are there any other tools or resources that are helping to push the field of document parsing forward?
There are some fantastic open source tools and libraries that provide researchers and developers with the building blocks for creating their own document parsing systems. Tools like Drobid, for instance, are widely used for extracting and structuring information from those scholarly documents we mentioned earlier.
So it's like having a set of pre-built Lego pieces that you can use to create your own document parsing masterpiece.
Exactly. But even with all these advancements, document parsing is still a field brimming with open questions and exciting research avenues.
What are some of those key questions that researchers are grappling with, and where do you see the field heading in the future?
One major focus is on improving the robustness and accuracy of these systems, particularly when it comes to handling noisy or complex documents. Imagine an AI that can accurately extract information from a faded handwritten document or one with multiple overlapping layouts.
That would be game-changing for historical research
Oh.
or analyzing handwritten notes.
Right.
What about combining document parsing with other AI technologies like natural language processing? Is there potential for them to work together?
Absolutely. Integrating document parsing with natural language processing could unlock a whole new level of understanding and insight. Instead of just extracting information, imagine an AI that can actually grasp the meaning of a document,
Yeah.
summarize its key points, and even answer questions about its contents.
So we're talking about AI that can truly comprehend documents, not just process them like a machine.
Exactly.
That's an exciting vision for the future. What else is on the horizon?
Another exciting area is the development of more robust and accurate OCR systems that can handle a wider range of font styles and languages. Imagine an OCR system that can accurately transcribe text from ancient manuscripts or handwritten notes in multiple languages.
That would be incredible. And what about understanding and extracting information from diagrams? Is that something researchers are tackling?
Definitely. Researchers are developing new algorithms and approaches to decipher diagrams, including better element detection, OCR, for labels and annotations, and understanding of the diagram structure. Imagine an AI that can not only recognize the different components of a flowchart, but also understand the relationships between them and extract the underlying information.
So we're talking about AI systems that can truly see and understand documents in all their complexity, from
Yes.
text and tables to charts and diagrams.
Mhm.
It sounds like the future of document parsing is incredibly bright,
It certainly is.
with the potential to revolutionize how we interact with information.
But before we get carried away by the possibilities, I think it's important to delve into the nuts and bolts of how we evaluate progress in this field.
Okay.
Let's take a closer look at those data sets and evaluation metrics that are shaping document parsing research.
That's a great point. Understanding those building blocks is crucial for appreciating the advancements and identifying areas where more research is needed. So let's dive into the world of document parsing datasets. What are some of the key datasets researchers are using to train and test their algorithms?
There's a whole range of widely used datasets, each with its own strengths and limitations. Some datasets, like FUNSD, are relatively small, but offer valuable resources for parsing form and document structures. They provide annotations for text blocks and relationships, which is crucial for training algorithms to understand the structural nuances of documents.
So these smaller datasets are like the training grounds where AI gets its initial grasp of document parsing basics.
Yeah.
What about the larger datasets? Any standouts there?
There are several.
Hmm.
The SROIE dataset, for instance, features thousands of receipt images and is focused on training AI to extract those key bits of information like company names, dates, and total costs.
So it's like training an AI to be a super efficient accountant, able to process stacks of receipts and pull out the relevant information in a flash. What about datasets for more specialized tasks, like mathematical expression recognition or chart parsing?
There are specialized datasets for those tasks as well. The ICDR dataset is a popular one for mathematical expression detection and recognition, while the chart dataset focuses specifically on chart classification and data extraction.
It's like having different training gyms for AI, each one tailored to a specific document parsing skill set. But datasets alone aren't enough, right? We need ways to measure how well these AI systems are actually performing. That's where those evaluation metrics we mentioned earlier come in.
Exactly. Evaluation metrics are like the scorecards for document parsing. helping researchers assess the accuracy and efficiency of different algorithms and approaches. They give us a way to compare different systems and track progress over time.
So what are some of the commonly used evaluation metrics in document parsing research?
For layout analysis, metrics like intersection over union, IOU, and F1 score are frequently used to gauge the accuracy of element detection and localization. They essentially measure how well the system can identify and pinpoint the location of elements within a document. For OCR character error rate, CER, and word error rate, WER, are common metrics indicating how well the system transcribes text.
And I imagine for those more complex tasks like table recognition or mathematical expression recognition, there are specialized metrics as well.
You got it. For table recognition metrics like TEDS, tree edit distance-based similarity, and CAR, cell adjacency relation, evaluate how accurately the system extracts the table structure. And for mathematical expression recognition metrics like XPrate, exact match rate, and edit distance, measure how well the system can recognize and convert mathematical expressions into structured formats such as LaTeX.
So it's like having a whole toolkit of metrics,
Right.
each designed to measure a specific aspect of document parsing performance. But with the field evolving so rapidly, are these traditional metrics still sufficient?
That's an excellent question. As document parsing tasks become more complex and nuanced, we're finding that we need even more fine-grained evaluation metrics.
Okay.
They need to capture those subtle differences in performance across various document types and tasks. It's like trying to judge a figure skating competition solely on technical difficulty. You'd miss out on the artistry, the flow, and the overall performance quality.
So the evaluation metrics themselves need to evolve alongside the algorithms and approaches they're measuring.
Exactly.
Beyond metrics, are there any other tools or resources that are contributing to the advancement of document parsing?
Absolutely. The field is constantly buzzing with new developments, but we still have much to discuss, including those open questions and future directions that are shaping the landscape of document parsing research.
It's amazing to see how far document parsing has come, and it sounds like there's a lot of exciting research still underway.
There is. It feels like we're on the cusp of some major breakthroughs, especially with the advancements in deep learning and the development of those specialized large models.
It's like we're witnessing a paradigm shift in how computers interact with information, moving beyond just processing text to actually comprehending the meaning and structure of documents.
Exactly. And that opens up a whole new world of possibilities for how we access, analyze, and utilize the vast amounts of information locked away in documents.
Speaking of possibilities, what are some of the key open questions that researchers are grappling with? Where are the biggest opportunities for innovation in document parsing?
One area that's ripe for exploration is improving the handling of complex layouts. We've talked about those nested elements, irregular reading orders, and tables without clear boundaries. Those are still significant challenges for document parsing systems.
So it's like trying to teach a computer to read a postmodern novel with all its unconventional structure and experimental formatting. How are researchers approaching this challenge?
One promising avenue is the integration of semantic information into layout analysis. Instead of just looking at visual cues, the idea is to incorporate knowledge about the meaning and relationships between elements to better understand the document's structure.
So instead of just seeing a table, the system would understand that it's a table of financial data, which would inform how it extracts and interprets the information. That makes a lot of sense.
Exactly. And this type of semantic understanding could also help with other challenges like resolving ambiguous references or identifying the key takeaways from a document.
That leads into another area you mentioned earlier, the integration of document parsing with natural language processing. What are some of the potential benefits of combining these two fields?
Well, imagine a system that can not only extract information from a document, but also understand its nuances, summarize its key points, and even answer questions about its content. That's the kind of power we could unlock by merging document parsing with natural language processing.
It's like going from having a research assistant who can pull out specific facts to having a colleague who can actually discuss and debate the ideas in a document.
That's a great analogy. And this type of deeper understanding could revolutionize fields like legal research, scientific discovery, and even personalized education.
Speaking of revolutionizing fields, what about the role of document parsing in scientific discovery? I imagine it has huge potential to accelerate research and uncover hidden insights.
Absolutely. Think about the sheer volume of scientific literature published every year. It's impossible for any human to keep up with it all. But document parsing systems can sift through mountains of research papers, extract key findings, and even identify connections and patterns that human researchers might miss.
So it's like having an army of tireless research assistants working round the clock to analyze and synthesize scientific knowledge.
Exactly. And this could lead to breakthroughs in fields like medicine materials, science, and climate change, to name just a few.
It's exciting to think about how document parsing could help us tackle some of the world's most pressing challenges.
It is. But as with any powerful technology, it's important to consider the ethical implications and ensure that it's used responsibly. We need to be mindful of potential biases in the data used to train these systems, protect privacy, and ensure that access to this technology is equitable.
Those are important considerations. It's like we're not just building a bridge to knowledge, we're also creating the guardrails to ensure that it's used for good.
Well said. And as the field continues to evolve, we need to have these conversations and proactively address these ethical challenges.
So as we wrap up this deep dive, what are some of the key takeaways you hope listeners will remember? What's the big picture here?
I think the main takeaway is that document parsing is much more than just digitizing text. It's about teaching computers to truly understand and interact with information in a way that was previously unimaginable.
It's like we're giving computers a new set of eyes and a deeper level of comprehension, allowing them to unlock the wealth of knowledge hidden within documents.
Exactly. And this has the potential to transform countless fields, from scientific research to business operations to our everyday lives.
So after this deep dive, what stands out to you? What sparked your curiosity? What possibilities does this open up for your work or interests?
Document parsing is a rapidly evolving field with immense potential. I'm particularly fascinated by the integration of semantic understanding and the use of large language models. It feels like we're just scratching the surface of what's possible.
It's inspiring to see how this technology is bridging the gap between the physical and digital worlds, opening up new avenues for knowledge discovery and information access. And as document parsing continues to evolve, it's sure to have a profound impact on how we interact with and understand the world around us.
It has been a pleasure exploring this fascinating field with you.
The pleasure was all mine. Thanks for joining us on this deep dive. Until next time, keep exploring, keep learning, and keep diving deep.